Una secuencia.
What does that mean?
Ah, no sé.
No sé?
Una fórmula, no sé.
So sequences are something that happens one thing after another, correct? Does everybody have their learning target written down? Alright, so now we're going to talk about what it... Who said no? Come on. Come on. We're going to talk about how we use those in math. The first one that we're going to do today is arithmetic sequences. Tomorrow we're going to do geometric. We're going to find the pattern today, so you're going to be able to recognize them. And if I ask you to find the 4500th term, you're going to be able to do that. It's easy because we have a formula. It's crazy. Are you ready?
Yes.
All right. So now let's open arithmetic sequences. Now, looking at the outside, do you see how these increase by adding 5 each time?
Yeah.
That's a sequence. That's it. That's all you have to do. You just find the pattern.
So what would be the definition for that sequence?
A pattern. Numbers that increase the same amount each time. Alright, so an arithmetic sequence has a common difference. So the common difference is how much they increase each time. The one on the front increased by 5 each time, right? And was it adding 5 or subtracting 5? It was adding 5. Now you have a rule for an arithmetic sequence that we're going to use to find our terms. You write it as A sub n, sub means that it's below, equals A sub 1 plus n minus 1 times d. Now, n is the term that you're trying to find. So if I ask you to find the 23rd term, what are you going to plug in for n? 23. If I ask you to find the 54th term, what would you plug in for m? If I ask you to find the 6th term, what would you plug in for n? If I ask you to find the Batman term, what would you plug in? Fantastic. Now, A sub 1 is the first term. So looking at our sequence on the front, what was the first term of this sequence? 5. So you would plug in 5. And the common difference is how much you increase or decrease each time. That one increased by 5, so you would plug in 5 there. These are very, very, very important. Does everybody understand?
I love how you're whispering.
What part don't you understand? You don't understand that we're identifying parts of the formula?
Oh, no. Whose phone is that?
Alright, so now what we're going to do for our first example is we're going to figure out whether it's an arithmetic sequence or not. We're going to state the common difference and write the next term. So the first thing we have to do is we need to figure out how much this is increasing or decreasing. So let's look at A. How much is it increasing?
4.
Plus 4 or minus 4?
Plus.
Alright, what about right here?
2.
Plus 4.
Plus 4 again. What about from 1 to 5?
4.
And what about 5 to 9?
Plus 4.
Plus 4. So is that an arithmetic sequence?
See?
Yes, because those are all the same. So we would write yes. Now the common difference is how much they increase each time. So how much did they increase?
4.
4. So you write D equals 4. Now what would the next term in the sequence be? What's 9 plus 4?
13.
13. That's all you have to do. Does everybody see what I did?
No.
¿Por qué no?
Porque no entenderme.
Which part?
Todo.
All of it? So first, we saw that to get from negative 7 to negative 3, you had to add 4.
Okay.
Does everybody see that part?
So is that how the problem going to be set up? Okay.
Then to get from negative 3 to 1, you add 4.
Okay.
To get from 1 to 5, you add 4. To get from 5 to 9, you add 4. All of these are the same, so that makes it an arithmetic sequence.
Okay.
Now, the common difference is how much you increase or decrease each time. How much did we increase? So that's why it equals 4. Then, to get the next term in the sequence, you do 9 plus 4, and you get 13.
Okay, I got you. I'll just make sure.
Okay.
No worries. All right, let's look at B. To figure out how much they increase, you just subtract them. Just do 22 minus 15. Yep, so that's 17. What about 22 to 39? 17. What about 39 to 56? Is that an arithmetic sequence? Yes, it is, because they increase by the same thing each time. So what's the common difference? 17. And what's the next term? What's 56 plus 17? Are you sure?
Yes, it is.
It is. You were.
So, man, so you,
Wait.
so what would you get right there? 17 plus 17 or something?
What you talking about?
Like, how you get 73?
56 plus 17.
Or did you get 56 from?
Do you see this number right here?
Okay. So,
All right. Yes. Yes, you take the last term in the sequence and you add 17 to it.
Alright, so
That's how you get the next term. Now I want everybody to take a moment and look at that pattern. Take a nope, I don't want you to say anything. I just want you to look at it. You look with your eyes, not your mouth. Oh my gosh. Baby, we just looking. That's all I want you to do.
I'm not talking about that. I'm talking about like on the first one we added, on A we added, and on D we subtracted.
No, B we added too. Baby, it's increasing.
Why we added 4?
Because that's the pattern. To get from one number to the next, the pattern was adding 4.
I thought it was already my answer. I'm trying to get it.
I know, but you're asking crazy things. Alright, so how much do we increase from 8 to 9? 9 to 11. 11 to 14. 14 to 18. That is not an arithmetic sequence. So no. It's a series, not a sequence. So they have to increase by the same thing each time. This does not increase by the same thing each time. So it is not an arithmetic sequence.
Okay.
Now please do D without me. Don't talk about it, just do it. Good. Write it all out. Write yes or no. Tell me what the common difference is and tell me what the next term is.
Okay.
Please stop biting on that bottle. No. You are not 5. No, not yet. No. I will take off all the points from your table for the whole week. That's your grade too, baby. I don't know what you're doing. All right, so how much do we decrease this time from 19 to 12? -7. All right?
Oh, what did y'all get it from? I got
Okay, Pumpkin, do 19 minus 12.
Where'd you get 19 from?
It's the first term in the sequence.
I'm doing C.
We're done with C.
So you weren't supposed to do that?
We did it. We did it together.
Okay, I'm
It was a
thinking,
no.
Look, I did like that. I'm thinking 18 minus 4.
No, it's a no. So then you just go to the next one.
Oh, okay.
That's why I said we were on problem D. And everybody do problem D.
Okay, I'm sorry.
Okay. All right, so we decreased by 7. Now what about from 12 to 5?
Decreased by 7.
All right, 5 to -2.
Decreased by 7.
-2 to -9. So is that an arithmetic sequence? Yes. All right, what's the common difference? -7. And what's the next term?
Well, how did you get that? Because I was having trouble.
-9 minus 7. You just subtract 7. We're just subtracting 7.
You got it. You can do it.
All right, so do you notice that we are increasing or decreasing at the same rate each time? That's what makes it an arithmetic sequence. Now, that's also like a linear graph. So what we're going to do for the next part is we're going to graph this sequence. Now, to do that, first I want you to tell me how much it's increasing or decreasing each time. Is it increasing by 3 or decreasing by 3?
Increase.
It is increasing by 3. Now, this is our first term, correct?
See,
Write a 1 above it. And then it's our second term, correct?
2,
Write a 2 above it.
and 3.
And then this is our third term, and this is our fourth term. Now, a linear graph increases the same amount each time. It's the same thing as a sequence. So these are going to be our x values, these are going to be our y values.
Graph.
So what we're going to do is we're going to plot the terms in our sequence. So the first term is 1, negative 5. So we would go right 1, down 1, 2, 3, 4, 5.
2, negative
Wait, just wait. Does everybody see how we got there?
2.
All right, then we have 2, negative 2. So we go right 2, down 2.
You got
3, 1. You go right 3, and then
1.
up 1. And then to get to 4, 4, what do we do?
Go right 4, up 4. 4, 4.
No, we don't draw a line. Now, we said that our common difference here, it was increasing by what? 3. Good. Take a point. So what we're going to do now is we're going to prove that our slope is also 3. So to do your slope, remember you count your rise, then your run. So how many do we go up to get from this point? And then 1. What's 3 divided by 1? 3. So that works. All right, now let's count our rise and then our run here. How many do we go up?
Pass the 1 off.
And then, okay. Now last one.
Pass 1 off.
Awesome. We did it right.
I know what you did there.
It's the slope.
It's stairs.
Yes.
Okay, so how do we start? How do we start from down here?
Because you always start from the left of your graph and go to the right. That's the left of our graph.
No, I'm not understanding that.
Okay, do you understand which side is the left?
Yeah, that's the right though.
This is the left side of our graph. The right side of our graph is over here. This is the left side of our graph. You see what I'm saying? So then you go up and then right. Up and then right. Up and then right.
Yeah, I got it. I'm just trying to make sure that I don't get into something like that. Like, I don't know where to start. So.
You always start on the left. In any graph, you always start on the left.
Right there, that point.
Yes, on the left.
All right.
All right, now let's look at the bottom. Are we ready? So what we're going to do is we're going to write a rule. Then I'm going to give you a term to find. Now to write a rule, we use that formula at the top. And in case you don't know how to look from the top of your paper to the bottom of your paper, we're going to rewrite it as A sub n equals A sub 1 plus n minus 1 times d. That's the rule that you use for arithmetic sequences every time. Now, is this sequence increasing or decreasing? It's increasing. And how much is it increasing by?
5.
It is increasing by 5. Is it increasing by 5 each time? Yes. ¿Por qué no? Okay. All right, now to write a rule, you plug in what you can. We don't know what term we're looking for, so we're just going to write A sub n equals. A sub 1 is which term? Which term does it say it is at the top?
It's the first term.
It's the first term, which is negative 11. Good. Natalie and Paris, take a point. So negative 11 plus. Do we know what n is yet?
No.
Nope, we don't know what we're looking for, so we just write n minus 1. And what's the common difference? 5. That's our
We
rule.
have to put it back in quotation. The 5 in quotation.
It's not quotation marks.
That's gonna, whatever.
Okay. Where A is our first number.
Yep,
And you minus 1.
yep.
So it's always going to end.
Unless I tell you to find a term, which is what we're about to do.
Okay.
If it asks you to write a rule, this is what you're...
And however many is increasing.
Yep, that's your D. Alright, so now what I want us to do is I want us to find the 67th term. I want us to find the 67th term. Now, do we really want to add 5 67 times? No. That would be craziness. So, what you do is you write A sub 67 equals negative 11 plus 67 minus 1 times 5. So all we did this time was we plugged in 67 for n. That's it. That's all we did.
Okay.
Does everybody understand?
Yes.
Now you have to simplify it. Do I need to zoom in for anybody?
No.
I will zoom just a little bit just to be safe. Ever, can you see? Okay. Is that better? Mucho better? Okay. Alright, so now what you're going to do is you're going to do 67 minus 1.
Wow. I wonder what that is.
Alright? And then you're going to do 66 times 5. What's 66 times 5? And then you add negative 11 to it. Reggie, why don't you get that calculator in front of you and work these out? What? In your hand? Well, come on, son. 66 times 5 plus negative 11. And what is that, y'all?
319.
3 what?
319.
319. Did anybody else get 319? Fantastic. That's all you do. Are we ready for the next one? ¿Por qué no? Okay.
Alright, first still.
We're not ready yet. Are we ready?
Are we going to school this summer?
Yes. Alright, so how much is this one increasing each time? 9?
13.
Alright, so this time it would be a sub n equals, what's our first term?
4.
4 plus, now do we know what n is yet?
No.
Nope, so we write n minus 1 times what?
Times
9. Yes, it would be helpful if you wrote it down. Does everybody see how we got that?
Yeah, I got that. I got right now.
Okay. Alright, so now let's find the 67th term of this one. So let's write a sub 67 equals 4 plus 67 minus 1 times 9.
So we always going to use 67?
Nope, just for these examples. If I told you to find the 64th term, what would you do?
Use 64.
Yes.
Okay.
Alright, work it out without me. Let's go, let's go. Are you working this problem out?
I'm done.
No. You should be working this problem out. No, Eric. Work the problem out. Okay. I don't know. I haven't worked this one out. English. You can keep saying it to me over and over again. Ocho is 8, so I know the end of it. And I think he's saying 500, but I'm not sure. 500 and what? 598? Did anybody else get 598? Fantastic! Good job. All right, now I want you to do the last one, C, completely without me. I want you to write the rule and then find the 67th term. Go. Is it positive 2 or negative 2? So what should you plug in? Okay, then. You can do it. You can do it. Do C completely without me.